Here's a look at number 22 from your energy review paper. A 0.047 kilogram golf ball is driven from the tee with an initial speed of 52 meters per second, and it rises to a height of 24.6 meters. We're going to ignore air resistance and determine the kinetic energy of the ball at its highest point, and we're also going to find the speed of the ball when it's 8 meters below that highest point. So initially, when you hit a golf ball, it's got no potential energy because it's just sitting on the ground. But it is moving because you just hit it. You hit it with the golf club, so it is going to be moving pretty quick. And in fact, it's going to be moving 52 meters per second. At the highest point, it has potential energy from gravity because it's up in the air. It also has kinetic energy because it's still moving outward. Think of projectile motion. It may have been done moving upward, but it's still moving in the x direction. So my equation simplifies to kinetic energy 1 equals PE2 plus KE2. I'm going to expand each of those, and I get 1/2 mv squared equals mgh plus kinetic energy 2. It's asking for kinetic energy, not how fast it's moving, so I'm just going to solve for KE2 and not make it 1/2 mv squared. I'm going to subtract mgh over to my left side, which is why I have 1/2 m initial speed squared minus mgh on my left side of the equation. I can plug in my numbers and get 1/2 times the mass, 0.047 kilograms, times 52 meters per second squared, minus 0.047 kilograms times 9.8 meters per second squared, times 24.6 meters in height, giving me a total energy of the ball of 52.2 joules. Now we're going to figure out when it's 8 meters below its highest point, we want to know how fast it's going. Well, if its highest point, which was given in the problem, of 24.6 meters, 8 meters below that is 16.6 meters. So that's our H for potential energy. We're going to be dealing with the exact same equation. Initially, the ball has no potential energy when it's hit, but it is moving, so we have initial kinetic energy, and we're now taking a look at 8 meters below the highest point, so it's still got potential, and it's moving, so it's got kinetic. So here's my simplified equation with PE1 canceled out. I'm going to expand each one of these. 1/2 mv squared equals mgh plus 1/2 mv squared. The m's cancel because there's an m in every term, giving me 1/2 initial speed squared equals gh plus 1/2 final speed squared. I'm trying to solve for final speed, so I'm going to subtract gh over to the left. So I have 1/2 initial speed squared minus gh, and that's going to equal 1/2 final speed squared. Dividing by half is like multiplying by 2, so I just put a 2 in each of the terms over on the left side, and I take the square root to get rid of the squared. Plugging in my numbers, I get the square root of 52 meters per second squared minus 2 times 9.8 meters per second squared times 16.6 meters is going to be my final speed. So the ball is going to be moving 48.8 meters per second when it's 8 meters below the highest point.